Hey everybody, me again. Sorry it's been a while. I've just been busy and a lot going on, personal life and work. Anyway, I got the parts in for this charger that I worked on some time ago, and I got kind of in between things right now, so thought we'd put that thing together, see if we can make it work, blow up or whatever. It's you know, this thing was weather sealed. It's got sealant all around it, so once we get the electrical part of it working, I gotta go in and clean all that seal and all that stuff off and get some caulk, you know, recaulk it and everything, put it all back together. My initial thought about when I first run into one of these, we had this on one of our generators, charging the battery on a generator, and I noticed it hadn't been working right, and I replaced it instead of just repairing it and taking it back out there. I just replaced it. So this one here is going to be my kind of a general purpose, you know, keep it alive charger. This is what it's made for. This is made for marine applications. It's made by Minnkota, which you know, they make trolling motors. Anyway, this is made to keep your trolling motor battery, and this is made to go in, you know, mount a boat, you plug it into a shore power. Anyway, for whatever reason, they decided this would be good to put on a generator. Okay. But I noticed that the charging light always stayed on. And when I measured the cell voltage, the battery was always like 12.15 volts. It wasn't very much. Generator always started, but it always was low. It never did come on full charge. So I went ahead and replaced it because I knew this thing had a problem. And of course, the new charger, I replaced it with the same type. Of course, a little bit newer, a little more electronics, which means I don't know how good that's going to be, because, you know, it's at a remote tower site, and it's, as you probably can figure, a tower is a lightning rod. So we don't know how, I don't know how well that's going to do. But anyway, I got the parts in for this dude, and I think I'll repair it. I feel brave this morning. I never did tell you the serial number of this thing, but it's an MK106 onboard battery charger. 6 amps total output, fully automatic, short circuit, reverse polarity protected, ignition protected, okay, waterproof construction, temperature compensated, for use with 12 volts, 6 cell batteries, 50 to 130 amp hour rating. That's interesting. Very interesting. Okay. Let me get everything ready and we'll start changing parts. Okay. Here's the device. As you can see, hang on, let me fix that. Anyway, sorry about my belly, but this is the rig right here. This is the circuit board. Let's see if I can zoom in on the damage that I've got to repair. Find me a pointer. This is a little bit of damage right here to the PC board, which is not going to be a problem there. I'll just bridge that with a little short wire. Not a problem. I think that's some damage right there too. That ain't no problem either. I'm not going to get real heavily worried about fancy schmancy. That's a fairly wide bridge there, so I think a little piece of wire there off the cut-off component will work just fine. I don't think it's going to be no problem there. And I think there's a rectifier and in here, and a regulator. One of these two. I don't remember which is which. But that ain't hard to figure out. Then I got 2 electrolytic capacitors that I've got to replace, and it should be able to test it. So anyway, let me zoom back out here. Let's see. Let me get my glasses. Alright, let's see. This electrolytic. Semis, another electrolytic. Okay. Yep. One of the parts is a STPS 2045CT mouser. One of my favorite places because I'm in Louisiana, they're in Texas. I order it today, I get it tomorrow. We used to have an electronics parts store here in town. They never was worth a crap. This having an ouser nearby is just as good. You can get better prices. Anyway, that's the rectifier part of the thing. And then the next one is an LM317. It's a adjustable linear voltage regulator, of course. So, first thing all we got to do now is figure out where all this mess goes. It's marked D1 right here. And this is marked U2, so it's kind of self-explanatory. I need to find the old components so I know how to bend the leads. And lo and behold, here's the old components. This is the Schottky. It's a Schottky rectifier, and I don't know. Find my pointer again. Right there. That little ball, that came from inside the chip. And right beside that little ball is a crack in the case. I know you can't see that. This thing got pretty warm. This whole leg, if you can see, is black. This thing has lost its smoke. But anyway, save the old components. Now I know how to bend my new components. So, let me get going on that. Let's see, let's grab the LM317T adjustable voltage regulator. Using standard ESD precautions. It'll be the same. I've never bought the fancy schmancy lead bender. I don't really need it. I've been doing this long enough. I missed it by just a thousandth of an inch. There we go. There we go. Leads are formed on that one. Give you a rectifier pack now. You know, I don't know. Get my chair here. I don't know. I bought this camera that I use. It was on sale. Not that I'm cheap, I ain't I'm not just brimming with money. I bought this camera that I'm using. It's a nice little Sony. I mean, but it's not. It doesn't have a handheld remote control. And I've seen some fellers on YouTube that use a handheld remote control. But I did find this thing has a boot, a mount that uses remote control. So I won't buy one, but the thing's expensive. I've been looking on eBay. Alright, right here is marked U2, so that's going to be the LM317, which is this guy. So that goes there. Part mobile soldering iron. Make sure I got the right part here. Get my third hand out here. Tell you guys, y'all need to get let me back up a little bit here. Oh, wrong way. There we go. Y'all don't need to see my gut. I have diabetes and I have a big gut, so. And it ain't from drinking beer. Wish it was. Okay. I use a Weller WESD51. It's a good soldering iron, but they don't have a whole lot of assortment tips for these things. And I'm going to buy a Hacko one of these days. Alright, the LM317 is in place. Now for the Schottky diode pack, STPS2045CT, which goes there. That looks like. Let me see something here. I need to go ahead and put that capacitor in there. Capacitor goes in. Be easier to solder it before I put it in. Before I put the component in there. I need to pause for just a minute. Okay, sorry for the delay. I had to look at something. Okay. Go ahead and put this capacitor in. I have to put it in first because where it's mounted, I won't be able to solder it easily if I put Schottky in there. So I'll go ahead and solder that in. Yep, leads. I'll need them in a minute. Alright. Now I've got a little PC board repair. Oop. Get the right tools for the job here. I'm just going to put in a little bit of solder here. I'm just going to bridge them together. A piece of this component that I've got. One bridge completed. Now I just have another one right here. I know you can't really see it that good. Alright. Reflow that. I need to run a lead. So I think the easiest thing to do, at least for me, you know, sometimes these leads, the lands on these boards are sized to determine, you know, sometimes they size them to, you know, according to the current that they might be running, because sometimes they're used as a fusible link. A little bit of cohesion there. I've gotten not nervous. My hands shake a lot. Maybe it's too much caffeine, I don't know. Maybe it's just because of a lot of things going on in my life. I don't know. I do need to make some lifestyle changes. Okay. Let that cool a second before I attack it. Let me get my magnifier out. Inspect these lands real quick. They don't look bad. Let me clean them. One of my favorite chemicals right here. Flux off. It's got this little tip on it. I love it. Yeah, it don't look bad. A little bit of something right here. Give it another little dose. Alright. Just for grins and wiggle. I'm going to measure the resistance between these leads. Okay, no shorts. If I can zoom in on this. There we go. This is the repair. This land right here was open between the leg of this rectifier and this section right here. I just bridged it. I don't think there's going to be a problem. And then right here was the other bridge. I don't think that's going to be a problem. This is a little bit mess here, but this is because this board was coated. I'm going to probably recoat it with some enamel. So I got the capacitor in, I've got the transistor in. Matter of fact, I probably need to add a little bit more solder to that right there. Looks like it needs a little bit of help there. There we go. Yeah. Inspect this thing for any more loose connections. This thing was made in China, and it was hand soldered by somebody in China. You know, I remember years ago when I was growing up, everybody used to complain about made in Japan. Now the problem is everything made in China. Turns out things made in Japan was always high quality. Things in China are not. I think I got these two backwards. Yep, made a mistake. That's why you should document this stuff. Take pictures. Messed up. Yeah, it's not a problem. I can fix that. Not a problem. Put this little capacitor where the big capacitor came from, and vice versa. Alright. Be right back. Alright. I had to go back and look at my videos to verify where these parts came from. But now I know. No problem.
Mr. Sam.
Hey.
Good morning. How are you?
Well, yeah, sorry. I work at a radio station and gotta take care of my guys. Alright. Alright. Anyway, what was I saying? Yeah. Make notes where you take stuff off. Don't rely on your memory. I put the large filter cap where the little one goes and vice versa. Had to go look back at my video, my initial video, to figure out where these were. Kind of self-explanatory after I looked at it. Oh well. It's just a capacitor, right? Okay. There we go. All right. Do a little lead trimming. Whenever I can, I like to kind of grab the component lead when I cut it, keep it just flying in my face or into the electronics. So sometimes you're working on something that is complex, and you don't want that lead getting down there in the middle of it, because then you got to find it. You have to, when you cut a bunch of leads and they just pop and fly off, and you don't want those leads getting in your electronics. That makes your day very bad. Been there, done that. Alright, got the rectifier replaced. I've got the regulator chip replaced. Got the 2 filter caps replaced. Let's see. Let's look at this. I don't think I explained this before. So, AC power comes in. Toroidal transformer. I've got apparently 2 windings. I've got a low voltage winding, or a low current winding, a high current winding. So I haven't actually analyzed this. So anyway, this right here is the low voltage, the low current winding. And this is the high current, like a bridge. So the white comes here. That's going to be probably negative. With the case, the negative of the capacitors on this is the negative voltage rail here. Comes down all the way down. Everything grounded through that. Let's see. This is the output here, going to the battery. Okay, the black wire from that, so that is definitely ground. Alright, now the 2 high current red wires from the toroid transformer go here, which goes to each side of the diode, so that makes sense. The output of the diode feeds this filter cap. Okay, comes in through the regulator, out of the regulator. And does this little thing. Now I didn't check any of these other diodes, but I'm not going to worry about it. I don't have any heat sinks on these devices, but I don't think I need them. Now it's a decision that I have to make. I think this thing will work. I'm fairly certain it will. I mean, I can go in here with my little variac and all this mess, current limiting and all that crap. And quite honestly, one thing that I've been wanting on my service bench is it's one of those Minnkota variable AC supplies with current limiting, and they use it for, I don't remember the model number, but they use it for you know, safety testing things. Anyway, I'm going to power this dude up, see if I get voltage out. I don't have the heat sinks on here, but I'm not drawing any current, so it ain't like this thing is a pulse width modulated supply or anything like that. It's a linear supply. So I think we'll be fine. So I'm going to apply power. And matter of fact, hold that thought. I have a bench voltmeter that I use when I'm servicing stuff. So I've got this set up on DC volts. I'm just going to take and measure the output rail. And we'll see A, if it blows up, and B, if it works. I have this on the 20 volt DC scale. So, fire and hose. Look at there. Green LED, 13.51 volts. Green LED, I think it means full charge. Cool to the touch. I'm going to put just a little bit of a load on it. It's just a bulb out of my jump box. It's just any kind of a load is all I'm really concerned about. I'm not really concerned about. I've got a 12 volt automotive bulb here, but I just want to put it. It seemed to hold. I'm going to unplug it. It'll just drop down. I need a volt. That's another thing I needed. Well, that variable AC supply that has current limiting on it. So Minnkota makes it. And it's got two LCD screens on the front of it, voltage and current. And you can set your current limit on it. I really want one of those things. And the other thing I want is a variable load. If I use that variable load, I can measure how good this thing works. You know, what this thing does basically is senses the battery, and it says, you know, the state of the battery. But so far so good. I'm going to do a few things. I'll be back. Well, I wasn't going to include you guys on this right here because it's kind of boring, I think. I don't like videos where people sit there every damn little step. But I'm going ahead and assemble this thing just a little bit. Get these heat sinks in there. I mean these transistors in. Get it applied to the heat sink here. I just want to get it in here. This heat sink's a little bit compromised. This little bar right here. Zoom you guys in. Okay. These are the two transistors. That's the transistor, I mean the regulator and the rectifier components right here. Got the little heatsink covers on them. Anyway, this little bar goes right here. There's a screw that comes through the case and attaches to that, and that's what attaches these heat sinks. So I have to center this over the top of the transistor, and at the same time these three LEDs, which you saw a while ago, has to point into these holes here. So it's not really exact. I kind of just threw it in there, kind of did the best they could. This thing has some design shortcomings. Peel this label off. We're back. Give me a Phillips. All right. We can get it started. Sometimes you got to be very dexterous. Whenever I find in my older age, my dexterity is kind of went out the window. So get this thing started without cross-threading it. And believe it or not, I got it. Apologize. Let me back this thing up. Sorry about that, guy. You don't need a close-up of my noggin. Here we go. Make sure that we ain't got no shorts. That's the rectifier and the regulator. About where they need to be. I'd say it is. Do a little more testing on this. Is why I'm putting it back in the case. Do a little bit more testing on it under load. The LEDs right here. Kind of push them back in the little holes. Where I can see. All right. Next step, I can do this two different ways. I guess I'll check in the case. to either lead. Should be isolated, hopefully. Make sure that my transistors and all that, heat sinks and all that, doing what it should. Alright, so far so good. And we'll measure the voltage again. Make sure I didn't break nothing putting it back together. Yep, nothing to do but do. Here we go, fire and hose. 13.52. Green LED says it's good. Now I can put it on a real load. And I just happen to have a battery here. Attached to a radio. I will disconnect the radio. So I do not want to blow this thing up. So I'm going to put it on a battery. I'm going to measure that DC voltage. Feeding the battery. It looks like the voltage is a little low. I would have thought it'd been 13.8. So I may still have some issues with this thing. I don't quite like that voltage being so low. Plug the device back up. There's a battery. .3 volts. The charging LED is on. There's a relay in here. I forgot about that. There's a relay in here. Apparently it disconnects the load when you turn the primary power off. I'm not sure how much current. Something else I need to get is a DC amp meter, clamp on amp meter. I guess I could put a bench meter on it to see how much current is flowing through it. Not really digging it. I'm not digging that actually, guys. As you well know, float voltage should be over 13.8 volts for a battery, for lead acid battery. Charge them usually, I'm used to seeing 14. Around 14 volts. I have a radio that I listen to on the bench here for you know, local radio traffic like ham radio and stuff like that that I listen to. Is attached to a battery which is hooked to a charger. Not a charger, I'm sorry. A bench power supply. Anyway. See, I'm going to unplug all this mess, take this back out, and I won't bore you that. I'll be right back. Okay. I'm not happy with how this thing's behaving. Yeah, I don't know if it just died because of voltage surge, or it could have been a lightning strike. Like I say, this came from a tire site. But there's a U1. Don't know. Wait a second. Anyway, U1 right there. It's a 14-pin chip. It's marked 2374071 revision B. Now, it normally tells me that that's a custom-made chip, perhaps. Who knows? I wouldn't think that'd be a board revision. If it was a board revision, I would think that would be I just want to poke around the circuit a little bit. And see. Really need a load on this thing, just a slight voltage load on here. So let me find a load. Well, I just want to put a load on this thing before I measure. Okay. Alright. This is where my adjustable load would come in handy. So what I'm going to do, I just need a little bit of load to put on this power supply. Just a little bit. I'll ground my voltmeter. My voltmeter set on 20 volts. And what I've got for load I just need a little bit of load. So, don't have any load resistors. I wanted a half amp load at 13 volts, which is roughly 30 ohms. I don't have that. But what I've got is this little 12 volt fan. 12 volt rated fan. 0.13 amps. Close enough. I think I can run 0.13 amps through these two semiconductors out. Letting any smoke out. So anyway, let's power this stupid thing back up. Green LED. Let's see. Go ahead and measure the output voltage again. Output voltage is 13.5 volts. Let's see. There we go. Let me put this where we can both see it. A little bit of a glare. There, you can see it, I can see it. Okay. There's no low voltage, 13.548 volts. Here we go. I'm going to put the fan on. Drops it down to 13.24. And the green LED is still showing. Rectifier is cool. Regulator's a little bit warm, but I think it's fine. I want to measure the regulator. Let's see. This is the rectifier here. This is the regulator here. What I'm going to do. Regulator is a little warm. Let's see if I can find a heat sink for it. Well, of course I don't. I'll just have to watch the load on it. Alright, anyway. Let me see. 12.76. 14.01. 18.70 volts. 18.07 volts. This is the input to the regulator. This is the output right here. Theoretically. 14 volts. Okay. 13.48 there. Up here. A little bit of a voltage drop. My goodness gracious. Somebody has a 30 amp fuse in this thing, I kid you not. A little voltage drop in that lead there. .99. The output of that. I'm losing half a volt. Losing half a volt in here, guys. How is that happening? No current. Shouldn't be that much of a voltage drop. I guess it's a red herring. Alright, measuring. Yeah, I'm losing 0.513 volts between the output of this regulator, which feeds this white lead right here, which feeds this guy. It's strange to see that much voltage drop across a lead that ain't got any current flow through it. Interesting. What's other interesting is it's okay. Yeah. What happens when you're OCD? I'm not sure I should worry about that right now. That could be normal. More than likely is. Anyway, this is the feed to the chip right here. This is the input. I have 18.25 volts. This is the drive to the chip. I'm reading 12.74. So this regulator should give me about that much. I've got 14 volts coming out of it. That's under a 1/4 amp load. I'm sorry. Output is 14 volts, no load. 14 volts under load. I have a lot of loss on that little cable. That's what's interesting is what's interesting to me is the open circuit voltage. To me, is not high enough to float. Not high enough to float a regular lead acid battery. We have two VRs here. VR2 and VR1. I'm sure one of them is going to be voltage, the other one's going to be current limit. I think something of that nature. I'm really curious to know what that chip is. That's when I took a picture of it a minute ago. I'll replace this tag if I decide. Let's see if we can figure out what this chip is. I'm going to use my fingernails so I don't. That's interesting. 142XX. Well, that's interesting. LM2902. Let me get my data sheet on that. Okay. It says LM2902N. Get it over here where we can see it, guys. LM2902N on the bottom. However, it has some other weird part number on top. But the LM2902 is a quad operational amp. I wasn't expecting it to say that. So, reverse engineering. I'll say the input here. Goes through the jumper. Goes to the arm of this control input from the element 317. Goes through the arm of a control. Transistor and all this mess. Pin 4 VCC. So this is pin 4 right here. Reverse engineering. Just to verify that that's what that is. Now the regulator. U3. So U1, U2, U3. So, just for grins and wiggles, I want to see. It looks correct though. I'm going to see if I'm getting what I'm getting out of that chip. Let me find a safe space. Showing 7.47 volts. 7.47 volts. Well, kind of an unorthodox power supply, that's for sure. I'm bound and determined to blow it up. Pin 11 is supposed to be ground. I'm showing a half a volt. I don't know. I really didn't want to adjust anything on here. Because everything, all things being equal, the thing should work. Well, yes. It doesn't tell me what U3 is that I can see, which is kind of funny because everything else I have the components on. Doesn't tell me. I don't know what it is. We've got about 7.58 volts on the output. There we go. Don't know what it is. Make sure that we ain't got no voltages on here. Where I go. I'll see that. I'm just gonna pull the chip. See if I can get any values off of it. Absolutely no markings on this component. I don't think it was intentional by the manufacturer. I think it's just coated, just black good. to use. So I wonder if I can scrape it off with my fingernail, of course. I just want to know what it is. I wonder if a little heat from the soldering iron get that off. Nope. Starting to see some numbers. I need something a little less destructive. Scrape with. See a 4, 3, and a 1.
She never got the bill, that's why she never paid it.
Okay. I think I found it.
This is the K5 NOE receiver, code 12103.5.
Let's see, TL 431, maybe an A. I think we'll see if I can find it. Okay. TL 431A is a programmable reference. I had a feeling it's going to be one of them. So, I'm going to call it good. Clean that PC board off a little bit. Put the IC back in. Okay, at this point, my thinking and their thinking, I think, are going two different directions. I'm expecting, with no load on this thing, to have a voltage of around 14.25 volts. That's what I'm thinking for float voltage. Well, that's charge voltage. So I guess around 13.8 is it should be its normal voltage. It should charge at a high level. If I put a load on this thing or a battery that needs charging, it should come up. That's what I'm thinking. So I'm going to put this thing back together. You know, maybe it's because it's Monday and I'm just not thinking straight. I tend to do that on Monday sometimes. So what I'm going to do, I'm going to put all this mess out of my way. I think my thinking's flawed on this. I really thought it should do something different. Maybe it's because I'm thinking backwards this morning. So I'm going to put it back in its case where I can utilize the heat sinks again. Alright, so I'm going to put it back in its case where I can use the heat sinks on it. I'm not going to adjust anything on it. And put these back on. Insulators. We ain't got no shorts. And put the heatsink tab back on there. I'm just going to hook it up to a battery, which is what I should have done in the first place, and let it run to see if it charges. I've had this radio on the battery now for about 30-40 minutes. It should deplete it enough to where this thing will do its job. Tactile feedback challenge today, I think. Alright. All that's taken care of. Full charge, LEDs on, good. Get back up to this battery that I had. Now, this is an SLA or sealed lead acid that I'm using. Yeah, I'm sure if anybody's watching this, they're probably screaming at me right now. Hey, you can't do that with the SLA. Well, yeah, it's close enough. I can do that. I'm just going to measure the battery itself. Got my voltmeter. 20 volt scale. Alright. Alright, here we go. That's the battery voltage. This thing is off. I do not have it connected. Red lead here connects. No. Showing full charge. 13.10 volts. What I'm going to do is I'm going to discharge this battery. Actually, I have a better test. I've got an older battery that I think has a problem. I'm going to hook it up to you. See what happens. Right here. This battery here, I think it's bad. Good test for it. So, yeah. Just click on this fuse, perfect place, terminate this thing. That battery is showing 10.23 volts, which indicates a bad cell. Let's see how this thing responds. It says full charge, and I know this battery ain't good. Okay, let's test the short circuit protection. It ain't gonna happen like that. Short circuit. Short circuit. Says check connection. I know that battery's bad. It's got an open cell in it. Of course it ain't gonna work. Yep, got two more here. So, let's see. On my grounds. There's ground. Voltmeter ground. Alright. Voltmeter positive. Power supply output. So you can see this voltage says 2.4 volt. Yeah, who do you trust? That battery's not. It's got an open cell on it too. It's just doing what it thinks it should be doing. This is the voltmeter over here. 6 9.8 volts. Yeah. I'll have a decent battery. So I want to test this. I want to test this thing under a battery. However, I don't have a decent battery. So I'm going to kill this video. I got the other things to do. I'm going to let this good battery here discharge till about this afternoon. Let it discharge pretty good bit, and then I'll put this charger back on it and see if I can get it to show me it's charging. And I want to go from charge to back to normal. So anyway, see you in a while. Okay. I've connected the radio back up to the battery after it's discharged a little while. I have my voltmeter, my bench voltmeter on there. 13.142 volts. Connected the charger. It says charging now. So basically all I have is my bench voltmeter measuring across the battery, and then the output of the charger connected to the battery. So right now it's 13.1498 volts showing charging. So I'll come back to it if something changes in the positive. In other words, if I get a full charge, then I'll see what the voltage is. But right now the radio's on. I'll turn the radio off to get rid of the load. So now we're up to about 13.19 volts showing charge. So I'll just keep an eye on it. I'll get back to you. Okay, about an hour or so later, we have full charge, and we're reading 13.265 volts. I'm going to call this thing good. I'm going to call it repaired. I just need to clean it up, put everything back together, seal it, put some terminals on it, and it'll be good to go. And I'll try it on a truck battery, or a regular lead acid battery that goes in a vehicle or whatever. And I think it's going to be good. Anyway, thanks for riding along. Sorry to bore you, but one less thing I got to worry about. See y'all later. Alright, second day of this repair. Finally got it back together. Can't see my display. Not that I'm old, just had it pointed on. Anyway, that's the finished product. A little beat up, a little dirty, but you know, in this case, looks don't kill. So let's see here. I'm going to turn it around where we can see this thing operate. I'm going to test it one more time now that I got it back together. Let's see here. Test it function. I've been running this radio here. On this battery all night. It's been charging all night. I'm just going to make sure it works. And the charging LED comes on. Measure my battery voltage. Battery voltage. It settled out at 13.3 volts. I believe it's working. Alright, that's done. Poke a fork in it. I'm confident it's repaired. Not sure what I'm going to do with it, but it's repaired. Something I can scratch off my to-do list. I got some other projects in the store. Some of the stuff that I worked on, like that old Dumont oscilloscope that I worked on in a previous video. It's going to be a while before I work on that because I'm having to move out of my house and I'm having to shut down my shop, sell my shop building. I'm going to be moving. I don't know when I'm going to get to it, so it kind of pains me that I got a place I've been living in for almost 15 years. I got to live. I got to move out, move in a temporary place so I can have enough money to build up until I can buy a house. I didn't really see this coming. I should have, but it didn't. But it's done. It's done. Anyway, this project's done. It was kind of fun. It's kind of nice to be able to work on something every now and then instead of computers all the time. Anyway, you guys have fun. I'll see y'all later.